created by Karen O'Loughlin. Hello, we are going to begin our coding journey today. We are going to do that by first reviewing the problem-solving process using an IPO model, introducing you to Coral, the programming environment we're going to use, and then provide you a coding example to help with your labs. So if you remember, our problem-solving process is to define a problem, get ready for it, think ahead, prepare, try something out. That's going to be our coding, make mistakes, reflect, and continue that process. The scenario that we are going to use for this is to find the area of a rectangle. Our pseudocode for this problem uses the IPO model and adds what we call a declaration section. We'll talk more about this when we get into coding and in our later chapters, but you want to declare the variables that you're going to need. We want to get the length and the width of the rectangle. That's our input. We're going to process by calculating the area, and then we're going to output the dimensions and the area of the rectangle. I'm very specific here that I want to output the dimensions and the area. I also have provided some sample output, and I've provided test data. So the more of this that you plan ahead of time, the easier it is going to be to code. The environment we're going to work in for coding is going to be called Coral, and we're going to find that in our Xi book. If you go to your Xi book in chapter 1, at the bottom of the chapter, you will have some lab spaces, and your instructor may have added a workspace, maybe not. It doesn't matter. You can always use the lab spaces to do this work. When you work in this environment, it's best to start Coral in Xi books. The reason for that is when you work in this space, your work is going to be saved. Coral does have an online simulator, but it won't save your work. So in this workspace, we are going to be working in an environment that looks like this. You will have a coding window, you'll have an input panel, and you will have an output panel. And we are going to model our area of a rectangle program here. The other thing I want to highlight is that every instructor probably has something that they want you to do for their course comment. And so, for example, I like to have you input your name, and then I like to have what section you are in, like CIS125, Tuesday AM, do a date, and then also do the name of the program. So this is going to be our Coral Introductory program, for example. Now we are going to learn how to work within this Coral environment. We're going to learn about the syntax of Coral, and we're going to review or use our pseudocode that we created for the area of a rectangle. So the first thing we have to do is to make declarations. Our declarations are when we declare a variable with a specific data type. In most programming languages, you need to give the data a type, and that's telling the computer what and how to deal with that particular piece of data. We will talk more about that as we go along. For now, you need to know that Coral has two data types, integer and float. I am declaring my length and width of my rectangle to be integers, which also then means that the area will be an integer. The name of the variable will show up over here in our variable section, and you will see when the data gets a value. The next thing that we're going to do is input. In Coral, input is very specific. We want to get input for the width and for the length. The syntax for that in Coral is to use the following phrase: get next input. It must be exactly like that in order for our inputs to work. You can copy that line of code, or you can type in the next one, which is to get the next input for length. Right now, our code will not display anything because we haven't outputted anything. But if we enter execution, in Coral to run your code, you enter execution, you click run, you can see the variable section has been shown up, and you can see that it's telling us we have a mistake. Program is trying to get next input, but no input values exist in the input box. That is because we didn't give it any input. This is how you put in or use input in Coral. You have to have values in this input panel in order for it to work. So let's try this again. The variables are set up. Now we have input. You can see that data is gathered and stored in our variables. So when you work in this environment, you'll have this input panel where you type in the input. You don't actually type it on the keyboard interactively. It's going to be pulled from this input panel, and then you're going to have an output panel. Now we're going to we're going to exit the execution so we can get back to coding. We will have our processing, and please notice how I am adding white space between these different sections of code. This makes it more readable for our user. Our processing is fairly straightforward. We're going to take length times width. If you notice, I just used an asterisk here, and asterisk means multiplication in programming. Our code will not output anything because we haven't told it to output yet. Just like with input, Coral has a very specific syntax for output, and that output syntax is the keyword put. Keyword means that you have to use that word just as it is written. Whatever you want outputted, you put in quotations if it is not a variable, if it's what we call a string. So I want to put length as a label, and then I have to follow it with the keywords to output. Those lines of code will output to the screen the word length. Now I want to output my variable. To output my variable, I follow a similar type of syntax. Put is a reserved word. I have to use that. Then I use my variable, and then I have to follow it with the to output. If I forget any part of that, or if I don't spell it correctly, it's going to tell me. Expected output format is put with a capital P, whatever you want to output, and the words to output. So you have to have those words to output. Now if I go ahead and execute, it's going to output our length to the screen. Our length was 30. We inputted the width first, and then the length, so our length is 30, so that's accurate. This little underscore you're always going to have there. And then the rest of your output is going to be similarly created. We're going to then put our widths to the screen, and if you want to put it in the same order that we gathered it in, you could. So we could do width first, followed by width, and then we're going to do likewise to get the area to print to the screen. So we have this combination when we do outputs of a label followed by the variable. So this is a label and this is a variable. I don't think it's going to let me comment like that. It doesn't. And so it wants the out. Well, it might be because I put in a period there. I don't think so though. This is showing you how when you run the code, if the line is not exactly how they expect it, it's going to give you an error message. In some programming languages, I can add a comment like this onto the end, but it's not allowing me to. So now if we enter the execution and we run, we should now see we have our width, our length, and our area, but we have a problem. Our area is not outputting the 300, so I have some type of an issue there. It's outputting the length. It also is running this all together. So I made a classic mistake when I did this. I used some copying and pasting. I have to exit execution in order to change this. When I copied and pasted, I have the variable width, I have the variable length, but when I copied for area, I forgot to change the variable to area. But now I have to fix where these labels are running together. And this is a very special trick. We are going to put in what's called a new line, and that is used with a /n. And you're going to see this in your Xi book. So when you see that /n, that's a new line character. The compiler will know what to do with that. It's going to say whenever it runs into a /n, that's a system command, it's going to put in a new line. So now when we go ahead and execute this, we should be able to see everything on the screen. We will see our width, our length, and our area. The last thing I would do, because I'm a little bit particular, is I would always want to have a label. So I'm going to say put, well, I need to do another, no, I don't need a new line. I'm going to say put square units. Notice I put a space before square units. When you do your coding in Coral, these spaces are going to matter. So if I want to have a space between my variable and the next item on the screen, I have to put that space in. We can also show you how, if you want, now that you've run this a few times and you understand that most everything's working, and again, I forgot my exact syntax. I have to do to output, and it's going to warn you if you don't use the exact syntax, just like it did there. But when I execute now, it should just immediately run through the whole entire thing, and I can see my output here. So once you kind of get things squared away, you can put it on instant execution in order to help with your troubleshooting. So what we have just done here is used our pseudocode in order to create this program. Our program has a declaration section. It has an input section, a processing, and an output section. We use a very specific syntax from Coral. We haven't shown you, but the Coral webpage, which is corallanguage.org, has a specification sheet. You will use this throughout the semester. That specification sheet shows you the syntax that I have been showing you. So for example here, the syntax for input is get next input. What they have in square brackets here is what you're going to have in your code in terms of your individual variables, but the get next input has to be exactly like this. Just like the output statements. Put is a reserved part of it. Reserved means that you cannot change that. Item is what we put in, and then to output has to follow. So you have just used variable declarations, input statements, and assignment statements, or you have seen them in this video. If you chose to code along, then you have used them. If not, you can use this as a demo video when you go to do your labs in your Zybook. If you go to the Coral homepage, you will also see a simulator, which is exactly like the environment in our Zybook, and you can use this, but you need to be very careful because it does not save your work. And that's why we would tell you to use the Zybook and use this environment, because your work will be saved every time you enter execution. One last thing I should mention here is the Submit for Grading button. You will have two types of assignments throughout the semester. You'll have a Lab that's auto-graded, and you'll need to submit for grading, and you will get feedback below that tells you what you did right or what is wrong. On an assignment where you're submitting it on Canvas, a Canvas submission, when you hit submit for grading, you're going to get maybe some messages, an error message, etc. That can be ignored if it's for a Canvas submission. And I'm going to show you again here. If I click submit for grading, you can see that it's keeping track of my history. That's very useful to us as instructors. So I would recommend that you submit for grading every 5 minutes, whether it's an auto-saved or auto-graded lab, or whether it's a lab that you are going to submit on Canvas. That should be it for your introduction to Coral. This environment is very limited on purpose because you are beginner coders, and we are wanting to take away all of the extra stuff to reduce the learning curve that you might need. And so we hope that you get off to a good start doing your first lab within your Zybook.